Module 9C, Energy Monitoring. Seeing is believing. Identify and evaluate energy monitoring elements in large energy user enterprises. Objective: understanding the importance of energy monitoring in controlling and evaluating energy performance improvement. Why are energy monitoring elements necessary? With ISO 50001 and ISO 50021, energy targets may be specified. Energy savings cannot be identified or quantified without adequate monitoring. To understand energy usage or to identify savings, energy usage must be measured. Therefore, adequate monitoring must be installed. To understand why energy monitoring is important, consider what helps an automobile operator and why. What would a driver know about the car's speed without a functioning speedometer? Or the car's use of fuel without a functioning fuel gauge? What would a driver know about the road ahead without a clear view? Without accurate metering and the recorded data obtained, what would an energy manager know about his area's use of energy? Here is a process of some efficiency, whether low or high. What can be known about the energy used? How much over time, or the energy use per unit output? The process may work well and produce. It may be profitable. However, without metering, the energy used by the process cannot be determined or verified. The efficiency is unknown. Effective monitoring and tracking, accomplished by installing a monitoring device on the process itself, can reveal how a process uses energy. The energy per unit of output may then be determined. Once the energy going into a process is understood, the energy manager may use this information to determine the efficiency of that process and the true cost per unit output. Which processes should require metering? Those using significant amounts of energy, or SEUs, such as heat processes and large numbers of compressors or chillers. While not a process, large numbers of high wattage light fixtures may consume significant energy in the facility and may merit tracking as well. For ISO 50001, effective monitoring and tracking begins with a defined scope and boundary. All energy going into this boundary must be measured. Typically, energy measurement for the boundary involves one or more revenue meters. Additional meters may be necessary should several buildings fall within the boundary, so that the energy used may be effectively monitored and tracked. Energy passing through the defined boundary and going elsewhere must also be measured. Whatever the arrangement, the metering should allow an accurate accounting of actual energy used within the defined boundary. Effective monitoring and tracking allow the energy manager to understand how energy was used over a period of time. Effective monitoring and tracking allow a baseline year to be established, usage in following years to be tracked, future usage to be anticipated, savings may be identified, as well as anomalies or problems. In the chart at right, an energy baseline for a period of time is established. Subsequent years may then be compared to the baseline. Periods of increased usage become apparent as well as periods of improvement. Thus, changes that help or hurt energy performance may be understood. This information may be used to calculate key performance indicators, or KPI, also called ENPI, or energy performance indicators. Energy tracking requires good data, and effective metering provides good data. Comparing actual energy use versus predictions allows the energy manager to determine the effectiveness or ineffectiveness of energy-saving activities. The success of this activity depends on accurate meters and recorded data. Many facilities actively monitor processes using SCADA or other systems. This monitoring facilitates the plotting of energy use over time that may reveal patterns. Peak usage and periods of wasted energy may be identified. In this example, energy use over time reveals that this process, a combustion air fan, pushes air against a closed damper for long periods of time. While the energy lost is small relative to the peak energy used by the process, the energy lost over a year's time may be significant. In this case, a better approach may be to turn off the blower at those times that its operation is not necessary. Site electrical power usage over time may be available from the utility. This kind of data allows monitoring of power usage during hours when production occurs and at times that no production may be occurring. In this example, covering Friday through Monday, including hours when no production occurs, it may be seen that significant power, roughly 1,000 kilowatts, is being expended on Friday night through Saturday morning, while almost 500 kilowatts is used during Saturday afternoon until Sunday evening, when machinery is activated and prepared for the Monday production cycle. This kind of data may be used to modify operational procedures to minimize unnecessary energy consumption. What types of monitors may supply the required information? Utility revenue meters at minimum. Sub-metering is possible in electrical cabinets supplying SEUs, that is, significant energy uses. SCADA systems may be configured to provide this and other data. Modern ASDs controlled by the SCADA system can supply power measured in kilowatts. Data loggers, typically on-off status devices, may provide useful information on the operation of line-connected processes. Process data labels usually indicate rated voltage and current. This information, along with the hours of operation as indicated by the data loggers, may be used to estimate energy consumption. In summary, effective metering and recorded data allow the energy manager to understand how energy was used in the monitored system, how effectively that energy was used and trends in energy usage over time, and the effectiveness of energy-saving activities relative to a baseline year of performance. The revenue meter typically provides site-wide data only, although some sites may have multiple revenue meters. Sub-metering on SCUs will provide more precise data on those systems using the most energy. Modern electrical switchgear cabinets may have this capability already built in. SCADA systems may already be in place that provide useful data on energy use as well as other parameters. In conclusion, effective energy monitoring allows the control and evaluation of energy performance and improvement. Energy monitoring. Seeing is believing.